with process when it comes to use cases that we cover, we started out primarily with fleet management systems. Fleet management systems focused on underground mines. We had a few geology products that we had discontinued. Then we started a heavy focus on shift planning and shift optimization to maximize mining intensity. And then the concept of short interval control came into picture and then got popularized by the GMG group. We were the first company that introduced peer-to-peer networks, especially in underground mines, and we continue to do that. We focus quite a bit of our effort in equipment telematics because that is the wave of the future. If you don't have an equipment telematics solution, you will not be a software or hardware provider for the mine, for the long run. We also do quite a bit of environmental health and safety and compliance. This has to do with software for monitoring tailing ponds, incident management, and so on. And then we also have a safety training learning management system where we monitor all the new miner training, the certification for Part 48, Part 46, equipment training, those sorts of stuff. Okay, and when you look at all the use cases in a mine, especially when it comes to operations, and when you separate that out into technical services, operations as in production operations, maintenance, and so on, we have a fair amount of coverage in terms of use cases. Wherever you see the orange color or brownish orange color is where we have a GroundHog product. Wherever you see the greens is where we have professional services coverage. Okay, and then this is a quick map of all the use cases to the products. With that, let's move on to the meat of the presentation. As most of you know, there's two kinds of people, right? There is the digital migrants, people like me that grew up when there were no computers and now use computers and technology almost every day. And then there are digital natives. If you're a bachelor's, if you're still pursuing your bachelor's, you've done quite a bit of your education on a computer, and using a phone or a tablet comes very natural to you. By the way, technology is not a 20-year-old thing. Technology has been around since time immemorial. What you define as technology has changed over time. The trends that you see today is new technology. For new technology, saturation is happening much, much faster. So when you consider the telephone as technology, it was introduced sometime in the late 1800s, but it took nearly 100 years before it received before there was saturation. That is, more than 90% of households here in the US using telephones. You can also see that during the 1960s, the introduction of color TVs, you see that they ramp up to that 90%, that saturation rate, was much shorter. And then with the internet is even shorter, and cell phone, right, shot up from, starting around 2000, where it was at about the 20% mark. It took about 5 or 7 years to get to that 90%. Okay, so new technology when introduced these days, if there is a product market fit, saturation happens super fast. On the right-hand side, if you can see this, is number of people using social media platforms, right? What you see is companies that started out, in the early 2000s had, a decent adoption rate. And software that is being released more recently, for example, WhatsApp, WeChat, and the best example now that almost everybody is familiar with, TikTok, right? Very fast adoption rates. So now with the prevalence of technology, you see adoption rates are going up significantly. Now, I bring up all of this because all of this impacts the way we mine. Okay. There's a group here out of Palo Alto. It's called the Institute for the Future, and what they do is they plot out these mega trends. I've given you a sample of one of their mega trends here. This has to do with delivery services and so on. When you talk to them, and I've talked to their CEO, many years ago, and he put it in this particular format, which kind of resonated with me, and I thought I'd share with you, is when it comes to digital technology, right? It looks like there were three big waves. They categorized it as three big waves, right? Wave one, from 95, from when Windows XP or Windows 95 started all the way until like 2005, is when most companies and even consumers were focused on computerization. That is, Bill Gates envisioned a computer on everybody's desk, right? So that decade from 95 to 2005 is when all of these companies started focusing on just computerizing all of their data, because until then, things were kept on paper and whatnot. Wave two is when there was a big focus on connectivity. This is to make sure that everybody had access to the internet, for example, either via their computers or via their phones, and also through social networks. This is when Facebook started taking off as well. So there is the aspect of technical connectivity and then also social connectivity, and then expanding your networks. And that's when a lot of these social media tools also came into prominence. Facebook, Twitter, WhatsApp, if you want to call that a social networking platform, LinkedIn, and so on. When you see now, we are now in the wave, in the third wave, which has to do with coordination. This is coordination across multiple companies, right, to get a particular job done. For example, right, if I have a meeting about 30 minutes or 30 miles away, Google Calendar recognizes that I'm meeting somebody 30 miles away, and automatically looks up traffic for me, and then informs me that, look, you should start 20 minutes earlier than planned, because if you start at 2:30, you will be late. So you better start at around 2:10 to take into account the 20-minute delay that is on I-80. Okay, so that's where coordination comes in. Is I have a particular use case. There are different components that need to work together. Another big example that people always give is, if I'm flying from San Francisco to New York City and then renting a car out of Hertz, right? And then trying to book, and I'm going to be staying in downtown New York at a particular hotel, right? Once I've taken off from San Francisco, if there's a weather-related delay in New York, and if I'm being rerouted to a different place, right, then the system should recognize that my flight's delayed, so I won't be able to pick up my car at Hertz, but we'll have to go to a different airport. Maybe I've been rerouted to Washington, D.C. for whatever example. So now my Hertz reservation also automatically shifts to Washington, D.C., and my hotel reservation automatically switches from the place I was going to stay in New York to Washington, D.C., right? So that's what we call coordination, okay? And with Uber, with what Tesla is doing right now, it's all, it all falls under that big mega trend of coordination, okay? By the way, if anybody has questions, please feel free to interrupt. More than happy to answer any questions. Okay. So with all of this, I mean, what does innovation really mean? There are two types of innovation. One is called incremental innovation, and the other is disruptive innovation. Incremental innovation is, look, I'm already using a set of tools and processes to achieve something, and an incremental innovation maybe takes that from, performing the job in 6 hours, now performing it in 3. Okay. Whereas a disruptive innovation is something where, I completely change the way something is achieved. Okay. I'll show you a few examples, right? So what's a disruptive innovation? Something like AutoCAD was an innovation, right? Life before AutoCAD, and maybe Kadri recognizes these, is people used to actually draw things out on paper, right? Yeah. AutoCAD came in and completely disrupted the way designs were done. Okay. Similarly, Tesla is now disrupting the the automobile market, right? Right now we have a huge ecosystem of dealerships, service technicians. There's a process that we always have in mind is, every 3,000 miles or 7,000 miles, I need to go to an oil change, right? And every 400 miles, I need to go to the gas station and refill my tank, right? Now, with electric vehicles, I don't need to go in for regular scheduled maintenance anymore for oil changes or things like that, right? You only go in for a down maintenance, for example. And with an EV, I no longer need to go to a gas station. I just, refuel, quote unquote, refuel at home, right? So I'm getting time back. And not just that, I also have increased performance characteristics, right? So when we talk about a disruptive innovation, we're not talking just about the battery versus IC engine. It's, complete different model of what you do around a car that you own, okay? Similarly, drones, right? Back in the day, and to a large extent even now, there's a lot of people that go out and do surveys, right? These are being quickly replaced using drones, right? Things become extremely fast. Everything's digital. You don't do any data capture. You already have your point clouds. You already, you can, by the time this drone operator goes back to the office, he already has all the file already imported into the system to start manipulating the diff files and things like that. Okay. And another big disruptive innovation that's coming into our industry is autonomous mining equipment, right? Because this just changes the entire paradigm around how we will be mining in the future, right? I no longer need to train operators, right? So we take the human element out of at least the active mining operation, right? I can work around the blasting schedules to increase my total utilization of available hours, right? I increase the overall throughput, right? And then if this was being battery operated, then I also change out the maintenance schedules and the maintenance cycles, right? So these are examples of disruptive innovations. Now, when it comes to incremental innovations, it's, maybe an algorithm within the software that, used to model out certain things and also import data via CSV files. The incremental innovation over there is by using APIs to connect two different pieces of software together, okay? So what are some of these trends, digitization trends that we see at mines, right? The fact is that mines need to deal with Darwinism. I don't know which side of the evolution debate each of you is on, but when it comes to companies, if you don't innovate, you die. If you don't adapt, you die, right? And this is primarily driven by two factors within our industry is, we are always under commodity price pressures, right? Whether a mine's open or not depends on the price of the commodity and the cost of extracting an ounce or a ton of that commodity. The other big trend that's going on in our mining industry is the mining workforce is aging and also shrinking. That's when you look at the total net new jobs or net new people coming into the mining sector, it's been going down, and this is across the globe, right? It's not a preferred destination, so to speak, like it was maybe 20, 30 years ago. Okay. So these two, to me, are two key drivers for digitization, because that helps you lower your overall cost per ton, which is super important for the mining companies, and also keep up with the reduced workforce that's coming into the sector. Okay, so I vividly recall Dean's keynote at the SME. I think this was in 2014 or 2015. But he basically, I don't remember the exact words, but he basically said something like this: is when you do a survey of all the technology out there, and what each of these sectors are using in terms of best of breed, cutting edge technologies, you'll see that the oil and gas industry, which is something that we are kind of compared to, it's the closest cousin, so to speak. The oil and gas industry is about 10 years behind on the technology curve. And then when you look at mining, you'll find that we are about 30 years behind. And there are multiple reasons for this, right? It takes time to adapt and adopt new technology, especially for us. And when you look at why this is happening, right, you'll see a lot has to do with, the industry in general is most of the decision makers at mines have tended to be a little older and have tended to be, okay with incremental innovation, and are pretty apprehensive about disruptive innovation because they don't understand it well enough. And they don't use that, quite often. I remember, when I first came to the US and went back to India, I tried to teach my dad how to use a computer. It took me 10 years. He still does not know how to use a computer, but now he's supposed to use the phone all the time, and he can access everything on the phone. So now he finally gets it, but it took him 10 years to get to the point where he could, text me back, right? So, and that's pretty typical about the old guard in the mining sector, right? The advantage is that, with fresh new grads coming in at these mines, as well as the OEMs and so on, is these folks have grown up with technology, right? They are digital natives. And they're very comfortable using software. They're very comfortable using computers. Oh, and the other thing is the old guard spent a lot of time and experience in learning a particular way of doing things. And then, for the new grads, there isn't that sunk cost, right? They're very open to using newer technology, and hopefully with the new crop of digital natives starting to become supervisors, mine managers, and general managers, I see an acceleration in adopting new technology, because the new folks are not as apprehensive of these disruptive innovations anymore. Okay. Now, a lot of mines over the past 10, 15 years have been investing in digitization. What you see is, and this is what you see is that digital transformation has been gaining a lot of traction since about 2016. And when you look at the maturity levels of activities, digitization activities at all of these companies, you'll see that a large majority is still ad hoc. That is, one engineer will say, hey, we need some software, or we need a better way to do this. And then they start adopting that new technology. Or 37% is opportunistic. What's most important is, there are some companies that have already optimized their process for adopting new technology. And then at least 12% have a repeatable process for introducing new technology into the company. The World Economic Forum had done a study on broad themes around digitization. And you can go look up this paper as well. The broad themes are around automation, around digitally enabled workforces, around integrated enterprises, platforms, and ecosystems, and also doing next generation analytics and decision support systems. All of these matter to us as graduate engineers and so on in the industry, because this is where the future is going to, right? You're looking at autonomous operations and robotics. You're looking at 3D printing. You're looking at smart sensors, connected workers. Mine operations are increasingly becoming remote, right? Where there is a tele-remote operator sitting in Sydney, operating equipment, in the middle of nowhere, Western Australia, right? There is a big push to converge IT and OT. There's increased focus on asset cybersecurity. You'd be surprised about the number of efforts to shore up, cybersecurity defenses at each of these mining companies, because there have been a lot of incidents, right? Again, the two other things is advanced analytics and AI ML, right? You hear a lot about AI ML these days. Digitization always goes through this sort of adoption curve. It's quite detailed. I will share this deck with Muthu, and he can share it with everybody else. But just know that there are early adopters who typically are in that top 2% that I had shown earlier in that pie chart. There's an early majority and a late majority. So early adopters are folks that always want to try something new. Early majority is companies that have a specific use case and are working with companies that specialize in having a solution for that particular use case. And late majority typically follows about 5 years to 7 years later, once they know that there's a sizable set of reference customers that are using a particular technology to solve certain use cases. Okay. This again is a map of how long it takes to reach scale. And it's categorized into short-term initiatives, medium-term initiatives, and long-term initiatives, and how long it takes to get to that level of maturity based on complexity and time as well. There's remote operation centers and smart sensors that you can deploy, anywhere within 3 years, right? If you want to do advanced analytics and simulation modeling, that requires a lot of data. It requires a lot of analytics, and then it requires a lot of verification that your model actually represents what's going on in reality at that particular mine or at that plant, right? The way you also, this is a quick pitch for GroundHog. Anything that you see in the orange rectangle is things that we kind of focus on. Okay. Technology is driving the future. I see every mine having a fleet of drones. to do various kinds of activities, right? From just mapping, managing stockpiles and figuring out volumes in those stockpiles, to mapping out your entire mine, right? And looking for structural deficiencies, changes in the point clouds and things like that. All of this done automatically. Okay. And this includes, going into a particular muck bay to figure out, how many cubic yards of material there is in a particular muck bay, for example, right? A broken ground inventory, all of that stuff. I also see autonomous vehicle technology being applied a lot more in mining. And this has to do with, autonomous haulage, shoveling, scaling, all of those use cases, and also for safety, right? Today, if I'm driving in a Tesla, right, I know when somebody is, less than 10 feet away from me, right? And I also, in that cockpit, I have representations of the two vehicles in front of me and on the side, right? And it's pretty accurate, right? From a shape identification and from the depth and so on. So this technology, I think, can be pretty easily applied to mining. Today, we rely a lot on high precision GPS on our shovels, on our motor graders, on the haul trucks, and those sorts of things. I mean, with LiDAR and with a combination of LiDAR and image processing, you won't need high precision GPS. It's a nice to have, but you won't need it, right? And then when you combine that with an always available drone image, right? Video streaming, all these activities, right? You'd be able to figure out, how your production is trending, potential hazards, all of that stuff in near real time, and then provide that feedback back to the supervisor so that, they can make data-driven decisions. Okay. There's a big trend to make sure that, every mine site is always connected. If not have 100% coverage, at least dynamically have that coverage wherever there is an asset or person in transit to that particular asset or that particular work area. And you can do that, either through a combination of LTE, 5G, peer-to-peer networks, and one idea that I think, if anybody is interested in a startup, is to have Wi-Fi access points on drones so that, your network becomes dynamically configurable depending on where you're headed to. In a facility, right? Today, you can dynamically turn on lights based on where you are within a facility. I mean, they use it to conserve energy and so on, but there's no reason why you can't do that with a fleet of drones to extend network access, both in an open pit mine and underground dynamically. Okay. Where that's important is when you have remote operation centers for performing the mining operations, as well as for doing survey, and also for debugging issues or providing maintenance. It's super important to have high bandwidth networks available at all times that are also reliable, right? And the other thing is, if I know that one of these nodes is malfunctioning, I can always send out a new drone to again recreate that link, rather than, in the current infrastructure, you always have towers, and on that tower, if something bad happens on that tower, or there's a malfunction, you actually have to send a technician out to replace the access point over there. So here is a quick and dynamic way to configure these sorts of mesh networks to make data available when it needs to be available, where it needs to be available. Okay. And then finally, AI and machine learning. There's a lot of applications. There's a lot of companies doing this. Is doing resource identification through AI models by looking up geophysical data, by looking up structural data, geochemistry, and all of that stuff. And then you can apply these same sorts of algorithms to also maximize mining intensity so that you also maximize the NPV of an ore body, right? And I mean, lots of companies are also doing condition-based monitoring as well as predictive maintenance using AI ML algorithms. Okay, so what does this mean for what sorts of jobs we will have in the future, right? In my opinion, data is the new gold, and I'm pretty sure a lot of other people share the same opinion. Is that data is the new gold? So with that mindset, the skills that are likely to be valued most in mining going forward is a heavy dose of statistics. People need to be pretty good at coding, whether it be in Python for AI ML or just RDBMS query query languages. Also, when it comes to databases, you need to be super comfortable in accessing data in relational databases and now in columnar databases as well, so that you can mix things up, pull data from different data sources and then perform analysis on that data set to gain insights, right? And not just that, I mean, you should also be able to feed all of this data in a way that makes sense for a machine learning algorithm, right? So, the future for most engineers coming out of school, to me, is they need to understand how to use data, interpret data, manage data, interpret data, and use that data. A lot of emphasis will also be on system integration. That is, I need to be able to integrate my geology data with my fleet data, with my planning data, and my financial data, and my HRMS data, right? I should be able to seamlessly integrate data from all of these data sources and then run analytics. And I should also be able to visualize this data in a way that makes sense to make data-driven decisions, okay? I also think that for the really successful guys, they will be really good at hardcore math because AI ML is going to be a very valuable skill to have. This may be slightly controversial, but just based on these mega trends, what I see is the jobs that are likely to see significant declines is anything that has to do with surveys, because they are being replaced by drones. If you go to construction sites, this is very, very apparent. Okay. Mine planning, right? I have a strong feeling that this will be displaced using AI and machine learning algorithms. And even, to a large extent, even geologists, right? Once you have drones going out, a field geologist goes out, does surface mapping, does rock sampling, all of that, right? I think a lot of that will be automated using a combination of, like I said, drones and sensors being IIoT. Same thing with environmental scientists, right? I mean, not as much environmental scientists as environmental technicians, because whatever activities that they currently do can be replaced by either having sensors out in those fields, and I'm not just talking about water quality, right? I'm also talking about using images for all the foliage and also detecting changes to the fauna and flora within an area and so on. Okay, so that's where all the computer vision and video processing skills come into play. I also see reliability engineers and mechanics having less work. Just like the amount of maintenance I need to do on a Tesla is pretty minuscule compared to what I need to do on my Honda, right? Just because there are fewer moving parts. Okay. And also safety managers and safety trainers, because most of the people I think will start being consolidated into these remote operation centers, and likely there'll be a lot more autonomous equipment as well. Jobs likely to see significant increases. People that know how to fly drones, at least in the short term, until these drone fleets know how to communicate with each other and then just go do their things, right? I mean, has anybody seen Minority Report? Okay, if you haven't seen that, I mean, there's a scene where one of these, cops come in and just deploy a few of these so-called ants that go and start looking for things and coming back, right? I'm imagining drones will get there in the next 5 years, especially given these sorts of advancements that Amazon, Google, and all of these other companies are doing in terms of last mile deliveries. I think there'll be a lot of requirements for IIoT sensor design. For example, mineral identification, doing environmental monitoring, those sorts of things. Maintenance techs, but with a different skill level, you have to now be able to figure out which subcomponents within the system need to be replaced. I mean, these are more like programmers that can look up code and then be able to identify issues. Network administrators, system integrators, and also if you're good with math and algorithms, right? Writing new algorithms for planning, routing. This is material routing, traffic management, blend optimization, and so on. Also analytics and reporting. The other jobs like a mine engineer, mine manager, I think they'll be stable, but you won't see significant increases in the number of those sorts of openings. Again, well, this is my view. The new grad skills, right, is I strongly believe that it'll go from mining engineers that know how to code to computer engineers and data scientists that know about mining. Okay. With that, I think I've come up to the end of my presentation. Any questions, comments? More than happy to answer.
Thanks, Satish. This was a great insight and a really good talk to see where the future is heading towards. Our audience, if you have any questions, feel free to unmute and ask currently. I have a couple from the audience, but if you have some pressing ones, you can begin with.
Yeah, this is Steve Enders. I'm the department head. Satish, thank you so much for your really, you would think it's future looking, but it's pretty much the present day and a little bit into the future where things are at. I think I agree violently with your view, and I've given a similar talk from a different perspective. So, but the one question that I had for you was a decline in safety managers and trainers. Help me understand that more, because that seems to be, I mean, unless we remove miners from the mines, it seems to me we're still going to need that human interface in terms of training and management of safety.
Right. I mean, I think over the next few years, I mean, within the next 10 to 20 years, the number of man hours required to move a ton will go down by at least, a half to 2/3. I mean, just given the fact that autonomous equipment start coming into play, and surveys again. I mean, not that the survey department is that big, but the number of miners required on site, I think, will go down significantly. And that translates into, do you need as much safety training? And then even the safety training, a few years ago, right, I've been at mines where they were just starting to experiment with tele-remote operations, right? Somebody sitting at the surface and managing a loader underground. Now, I've seen places where they have 4 to 6 of them, right? So the number of people going down the shaft have gone down.
Okay.
And
So
that trend is going to accelerate.
So the total tons moved per man shift is going to greatly increase.
It is going to greatly increase. And if they are going to stay, if the mine wants to keep it, straight line just because of the nature of the ore body and so on, you will just require fewer miners.
Sure. Okay. It's not that you don't need safety. It's just you need less of it because you have fewer people exposed.
That's right.
Okay.
That's right.
That's really helpful. Thank you for sharing that.
Sure.
Yeah, I think that's a totally valid point. I'm not sure if you saw any of the announcements Sandvik made over the last 2 days. I unfortunately missed their announcement about the autonomous loading concept they introduced, but if you see that, they basically just manufactured an electric loader that's supposed to drive completely by itself. There's not even a cap on it. And I think if companies like Sandvik start pushing so hard for battery and autonomous equipment, I mean, it's probably going to be a bit down the road, but
right.
Just makes a whole lot of sense. That's the only way how you can actually prevent risk or prevent harm to people, right? If you take them out of the equation. So,
and that is going to change the way we plan the mines going forward as well, right? That is for brownfield and greenfield operations. Now, how do you adapt that to already existing operations? That's something that you still need to look at.
Satish, you're referring to data science in terms of highly demanded individuals coming up from the schools. The data science fundamental ingredients is statistics, coding, and domain knowledge.
Right.
And I think importance of domain knowledge should also be stressed. And just teaching statistical tools without the domain knowledge cannot be effective.
You're absolutely right, Kadri. You need domain knowledge to know which factors influence other factors, because when people always talk about predictive maintenance as a perfect use case, right? They bring in all of these data scientists that don't know anything about mining or mining equipment, right? And then they start looking at the data, and then they say, hey, you know what? If the RPM is this value, you're going to see a breakdown over here, without understanding how these two interact, these two factors interact. So absolutely, I mean, you need the domain knowledge, and especially here in, when you're trying to find new resources, right? New ore bodies and so on, you definitely do need the geology knowledge and the mining knowledge.
Yeah, what we try to do in the mining department also is, we teach statistics, we teach coding to a certain extent, and then we mix that with the domain knowledge, and we call it geostatistics.
Right.
Yeah.
I mean, like Elon Musk says, right? To build any good system, you need to understand the first principles, right? What are the components that make up a certain thing? And you need to have a very strong understanding of those fundamentals. And, I can't pick up geology as a coder. I can't pick up geology without going to school, for sure.
Right. And so those has to be in the right balance.
Context is very important. And
Yeah.
yes, it all has to be in the right balance.
Thanks, Satish.
And I have one more question. How much mining companies are spending in terms of coming up with some of these apps? And they are very helpful. They can increase their productivity in terms of production, the rates per man hours and so on. But I don't see they are spending a lot of money to adapt some of these technologies. It's bothersome.
I think it always comes in waves. So when a mine decides to embark on its digitization journey, it typically thinks that, they are the best at doing it, right? So we've seen this at Rio Tinto, we've seen this at BHP, we've seen this at Barrick, we see it at Vale, we see it at Nexa, we see it at a lot of companies, right? And this is all public knowledge because they go out and, they sponsor these innovation tournaments. And then they bring in consultants to help them figure out, the digitization strategy. I'm pretty sure they spend, at least the major ones, I think they spend at least $100 million, if not more, across multiple years, right? Not all the initiatives are successful because it takes time. And then there is a big change management component. I mean, I don't have industry data around, how many millions of billions of dollars is spent every year on digitization. I'd be curious to see what those numbers are.
Yeah.
But I do know that through news articles and stuff, right? I do know, and also through their public filings, you sort of get a gauge for the amount of investments they are putting into technology. And the way mining companies talk about technology is there's two different things, right? One is mining technology and the other is digitization, and they separate that out. Mining technology is if there is a new process or a new technique for extracting minerals, right? Whereas digitization is, okay, fine. How do I use a combination of sensors, apps, and third-party software to achieve a higher mining rate?
Thanks, Satish. There's a question from Lucas. He has a couple of questions and he's been in line. Lucas, do you want to go ahead and ask it yourself? I'll read it out. So one of the main first question is from the safety point of view. When there are emergency and unknown situations, to what level people should be trained and to what level can it be given to technology? That's the first question he has.
See, technology has not evolved to the point where it is self-correcting, right? And it'll take a few years for it to get proven, right? So until then, there will always be the human element in trying to go and figure out, the root cause of a particular failure or a particular safety incident, until there is enough data collected to then start making to start having confidence in the way to deal with that particular incident or that particular breakdown or that particular issue.
Thank you.
That's why, all of these autonomous haul trucks, right? I know BHP has been running those at one of their mines in Western Australia for many years now. And it's primarily to collect all the data and understand it, right? And the sample sizes at mining companies is not as high as automobile companies. There's millions and millions of automobiles where Tesla, for example, just gets all data from their sensors and just keeps analyzing it, and then starts running simulations based on real driving conditions. You don't have as many data points at a mine site.
Makes sense. His second question is also something which I have been thinking, like, so in your last slide, you showed the shift between mining engineers being programmers, and then you have these programmers who are moving into the mining field. And you sort of suggested that the move is more coming from programmers because we have plenty of them and them moving into the mining industry, right? Is there a balance, or is it more like we're going to see this trend?
I don't foresee many programmers coming into the mining industry because I think they think that it is very complex. And I think they think that you have to have a mining engineering degree. So I don't see that many computer science people moving into mining. I don't see many job openings in the first place unless you want to build new software for that sector. Right? At all of these mining companies, if you look at all the job descriptions, you'll probably, you'll see a few jobs for IT, but none for software engineers, unless the company has embarked on a major initiative to digitize its operations and wants to do it in-house.
To what extent, so this is more of a follow-up on that, to what extent have you seen mining engineers get in the grooves of data science and programming?
Mining engineers that do software well, I've not seen many good examples of mining engineers doing software well. That said, let me give a pitch for us, is we are hiring. So if you think you're really good at software, you can come join us as an intern. And again,
ask you a question, if you would. So mining companies are, in my opinion, I observe that in many of their tasks, they actually outsource it, whether you're talking about tailings or anything else. So the basic sense of whether a mining company is going to itself in-house do anything, or whether they're actually going to outsource it. Do you see service companies coming up and actually being the people who are hiring to do this, or do you think the mining companies are going to be doing this?
So based on all the 8 years of serving the industry, what I see is these contractors don't invest much in digitization unless they are forced to, or unless they know they'll get paid for their digitization efforts. And typically they want to pass that on to the customer. So I've seen very few of these contractors reach out and say, hey, we'd like to digitize X, Y, and Z. I'm talking about mining contractors, as in the guys that go in and actually move material, for example.
So what I was wanting to say, though, is that most of the tailings operations, for example, are actually outsourced to service companies. And as a mining company decides to go digital, are there some that are doing it as outsourced rather than trying to build their own internal digitization capabilities? They actually contract out to a separate firm.
Is this for software to manage these tailing ponds and water?
Yeah. You bet.
So, I mean, we have one customer that uses our WaterSense product, but that was paid for by the company, and the contractors use the software.
Well, I think, I just suspect that the issue going forward is going to be if the companies are not hiring software people right now and big data people right now, they're going out and finding it somewhere. And I think that there may be a new sector of the service industries that actually do provide this service. And so be interesting to see if any of the service companies, if there's any coming up that are thinking about doing this, You
mean the digitization services?
Sure, digitization, sensing, anything to do with data. And they want someone to come and build and maintain their digital twin mine. In many cases, it's like Ronald Reagan back in the 80s, where government's not going to do it for itself, it's going to outsource it.
Right. I mean, there are a lot of companies that provide digitization services where people actually come in and code things up and things like that, right? So, I mean, Accenture is a good example. Deloitte is another example. I know McKinsey also comes in and has other people do that digitization, anything that has to do with coding, right? There are quite a few of those companies that just specifically focus on building custom code for both the mine operators as well as the contractors, yes. And there is definitely an opportunity there. There definitely is an opportunity.
Thank you.
Even for managing networks and so on, they just outsource it, right? And all they want to pay for is, bandwidth per hour, right? They don't care which router you put in. As long as you meet my service level agreements, they're fine.
So it's really a performance spec rather than a detailed, you will do this.
Yeah.
Instead, just give me this bottom line.
Exactly.
Yeah, that happens in the contracting industry, construction as well. Yep.
Right.
Okay, thank you very much.
For sure.
Awesome. Thanks, Satish. This is a great talk. It's also an eye-opener for a lot of us to see where we want to be in the future, take our paths. We'd be happy to have you in future on any other new topics you'd like to discuss with us. But unless we have any questions from audience, I'd like to conclude this session. Thanks for staying beyond 5 and listening to him, and thanks for answering the questions, Satish. It was really great.
Awesome.
Thank you very much, Satish. This was great 1-hour speech and presentation. I truly enjoyed it. Thank you.
Awesome. Thank you so much.
Thank you,
And
Satish.
thank you for your time.
Yeah.
I appreciate it. And thank you for setting this up, Muthu and Lucas.